All right, the first start is some vocabulary that we're going to keep using in here. So let's learn some vocabulary if you don't know it already. There is the degree, which we have to learn. There is what type, and some of these you already know the words for. There is the standard form, which looks way harder than it is. There's an example for each of these. And then we're also going to name them by number of terms. So I'm also going to add in naming by number of terms. So constant function is when we have like y equals or f of x equals just a number. That's constant. That would be we've talked about this earlier in the year, that would be like a horizontal line. Okay. The next is linear. That would be like y equals mx plus b. Right? We've done that. Here's an example. Y equals 5x minus 7. Oh, I forgot to do this over here. When it is only one term, terms are separated by addition or subtraction. That's how we separate terms. In the first example, how many terms do I have with negative 14? One term. We call that a monomial. One term is a monomial. Yeah. So then what's the second one? A binomial when it has two terms, binomial. The next one is quadratic, which has a degree of 2. We've got some number times x squared plus some number times x plus some number by itself. You've seen this like ax squared plus bx plus c, same concept. Here's an example, f of x equals 2x squared plus x minus 9, and that is what type of nomial? Trinomial. What we haven't done yet is we haven't done cubic. So cubic has a degree of 3. That means if you look at all the x values in each of the separate terms, the highest amount is 3. That's what degree means. It's like what is the highest amount in all of the terms of the variables. So here's an example of a cubic. F of x equals x to the third minus x squared plus 3x. Doesn't have a constant. What kind of nomial is this one? Okay. Yep, still try, because there's only 3 terms. Quartic is when we have to the 4th power for the degree, which means, here's an example, but when the highest exponent for the x's is to the 4th, that makes it quartic. See how that's different than quadratic, which we've been studying for 2 full chapters. So now we're moving on to other stuff. Finally, right? So here's an example. F of x equals x to the 4th plus 2x minus 1. What kind of nomial? Trinomial. Okay, polynomial is any nomial that has more than one term.
So all of them are,
except for the first one, all of them are polynomials. Poly means like many. If I did give you an example like f of x equals x to the third minus 3x squared plus 3x plus 1, if I gave you something like that, this is a polynomial. After 3 terms, they stop being special and we just call them all polynomials. Okay, after 3 terms. If they're 2 terms, binomials, trinomials for 3 terms. But after that, we're just like, I'm just going to call you a polynomial. You have too many terms. Okay. And then identifying polynomial functions. So there are some rules about polynomial functions. I'll just kind of write these off to the side. X has to have the exponent cannot be negative, When you've got x's in here, the x cannot be negative. The exponent on the variable cannot be negative. That would make it not a polynomial. Variables cannot be multiplied together. So like you can't have xy. That would not be a polynomial. Cannot divide by x. So we can't have like 3 over x squared. That would not be a polynomial. X cannot be the exponent. So like 5 to the x. That would make that not a polynomial. If I think of any others, I'll let you know, but I think that's all I can think of right this second. This says decide whether each function is a polynomial function. If so, write it in standard form, which I haven't talked about, but some of you already know, and state its degree, type, and leading coefficient. So for each of these, standard form, type, and leading coefficient. Okay, that's just standing for the things that they asked me to do. All right. Standard form has to be the x powers in descending order. X powers, leading coefficient. X powers in I'm not spelling it right. How do we spell descending? Was I spelling it right? Is there not an S in there? D-E-S? I just like blanked on how to spell descending.
What does that say?
Hold on. I got it.
Just like hold the hump. Hey Siri.
No, I got it. There is an S. I was right.
Nobody actually knew.
There. I'm sorry. This says x powers in descending order. When it's in standard form, you guys just saw a bunch of parabola or quadratics in the past chapter where it went x squared, then it went x, then it went in descending order. So looking at this one, is this a polynomial?
Nope. It's a trinomial.
Oh, polynomial is any of these that have more than one. So if it's a trinomial, is it a polynomial?
Yes.
Is it in standard form?
Yes.
Okay, so it's already... Gosh, my spelling has exited my body. Already...
Your math teacher is fun. When I was little, I thought all the math teachers were
What?
I watched the video because I wasn't here.
Oh, and I made a few mistakes.
No, every time Martin does an intro.
Oh, that one day.
Yeah.
I do remember that one day. Sorry, Martin. Okay, so it's already in STD form.
Oh.
D is degree. So the degree is what is the highest amount of x's in any of the separate terms. So that means it's what type? Cubic. And then the leading coefficient is, do you know what it is? It is -2. Okay, so the leading coefficient is whatever the number is that leads that first term, the number that leads that first term. All right, question B.
Wait, is that it?
Yeah, that's all there is.
Okay.
On this page,
Do we have to solve these one day?
yeah,
No, I give up.
there will be a calculator component to it, if that makes you happier. Okay, B, is it a polynomial?
Yeah.
It goes in ascending.
So standard form. Is it in standard form right now? No.
No, there's a square root. I don't know. I think.
You have to look at the powers of the x's. what term should go first? Square root 2 x to the 4th goes first. And then what? Minus 0.8 x cubed, and then minus 12. That is descending order, that's standard form. So then the degree would be 4. That tells me what type? Quartic. And my leading coefficient after it's in standard form is? Square root of 2. No, because the square root was already there. You only do plus and minus when you put in square root. I just thought of another rule of something that would make it not a polynomial. After doing that one, I just thought of another rule. Cannot have square root of x. That would be not a polynomial if it has square root of x. Square root of 2 is fine, but square root of x is not okay for polynomial. Okay. Question C. Is it a polynomial?
No. Nope.
I heard one of each.
No. Nope. Negative.
Okay. Bryce said no first.
Yeah.
Why do you think it's not a polynomial?
Wait, for this one, is it because the negative or the exponent?
Yes. Because exponents on x cannot be negative. Okay, and then question D. Is that a polynomial or not a polynomial?
No.
Why not?
The exponent of the x.
Not a polynomial because x cannot be an exponent. All right. We won't get through the whole packet. We'll get through most of it.
NAP.
No.
You put nap.
No.
Not a polynomial.
Hey, am I recording this? So could you go back and fill in your notes later if I go too fast for you? Okay. Or you can see my paper after class and just take a picture of it.
Still go back even when she's
Right. Example 2, I asked you guys to do. Just when you go through these examples and it tells you when x is 3, you're just plugging in 3 for all your x's. You're doing like f of 3. So 2 parenthesis 3 to the 4th minus 8 parenthesis 3 squared plus 5 parenthesis 3 minus 7. If you want to use your calculator, you just type it in with the parentheses and it will give you the answer. If you want to use your calculator, you can. If you want to do it by hand because you feel like you need to practice more, that's totally fine too. No, I helped people do it earlier. The rest of them I haven't done. Okay, why are we talking? It's turned around. There's nothing we can do about it right now. So this one, f of 4, is negative 4 to the cube plus 3 times 4 squared plus 9. I'll show you if I type it in my calculator correctly. This is the one where I walked around and a lot of you didn't have all the same answers. So I'm going to type it in my calculator and show you how if you type it in right, it is a trinomial. Negative 7. Okay, negative 7. So f of 4 equals negative 7. If I write it a certain way, then the answer is yes.
Do we have to do parentheses 4, negative 7?
No. You're just finding the value of x. So you just have to write, no, I'm sorry, you're just finding the y value, sorry, when x is given. On a graph, that's what it would mean. So f of negative 2 equals 3 times negative 2 to the 5th minus negative 2 to the 4th minus 6 times negative 2 plus 10. I'm going to type that in my calculator as fast as I can, which is not very fast.
How did you do that? Oh, I was about to do like.
How did I do what? Oops. I see. I'm fixing it. Negative 106. Negative 106. Negative 106. Oh.
I got negative.
I got negative 90.
I got 8.
I got
What I did wrong or what you did wrong? I did something wrong?
Yeah.
What did I do wrong?
Two negative 2's there.
Yeah.
What did I do? What did I do wrong?
Yeah,
Hold
we
on.
have two
You have
negative
a
2's.
negative 2 times negative 2 to the 4th instead of.
Oh, why do I have a... Oh, okay. My bad. I did it wrong. I typed it in wrong. Sorry.
Wait, how did you already get the whole equation?
Negative 90. If you want to learn calculator tricks, I don't have time for those right now, but I can show you calculator tricks if you want to know how I did something so fast. All right. We have to get through end behavior. That's the next section.
Example 2.
Okay. I'm going to pause it for a moment because I'm going to dance. We're going to dance. Okay, so we just danced. We did kinesthetic learning. So if you're in the middle of a homework and you're like, I can't remember, and then you got to be like,
Can we do that during a test too? Can I just stand up while we're doing the test and just like, wait a minute?
All right. So this has everything we just talked about. Odds, leading coefficient positive, leading coefficient negative. The odds are going uphill from left to right. The odds positive are going uphill. The odds negative go downhill. Evens. Both sides go up if it's positive. Both sides go down if it's negative.
Why is
The thing in the middle?
why is
Okay, so do you see how the thing in the middle for all of these is dashed? This is just an example of one kind of odd. There might be an odd that looks like this. Linear looks like this. Another odd looks like this. Another odd could look like the one they have. Like there's different ways of doing odds. So it has dashes in the middle because the middle is not really what we're looking at all. We're not even looking at that. It's just the ends that we care about right now. It's just called the end behavior, so we're only looking at the ends. So now some of them look like that. It is not quadratic. That would have to be the 4th power or higher to look like that. Right? A quadratic always looks like this. But when you get higher powers, the 4th power could look like this. Okay? Now, what you have to know is how to write using symbols the end behavior. That's what you're going to learn, how to write it in symbols. So I look right here. It always goes left to right. So I'm always going to look at the left side first. Then I will look at the right side again. Then we always talk about the y's first, or the f of x first. You know how when we write equations, we always write f of x equals stuff with x's in it, right? Yes. Okay, so we always do the f of x first, just like we would do in equations. I'm going to write the symbols here as I go. So you guys know what f of x stands for? It's the y, okay? So this is saying that the y and then this arrow means approaches. And then it's hard for you to, but this is a negative infinity symbol. That is telling me that the graph goes down forever. As, then it has a comma, and we say as x's approach infinity as well. Yep. There's all kinds of infinities. So negative infinity for the y's goes down. For the x's, where would negative infinity go for the x's? To the left. Negative infinity would be left. Okay, so I am telling using symbols that the function is going down when it goes to the left. So now let's talk about the right side. F of x approaches, so we look on the right side, where is this graph going? Up, which is positive infinity. That's up. Comma, as the x values approach, which infinity do the x's approach? The right, which is positive infinity. Okay, so that's all the symbols. They're just going to be different for each one, yes. I would assume it, I've never been asked that question, but I would assume it would be negative infinity.
It would be negative 2.
It would be more
If it's
negative.
numbers, therefore it's
Yeah,
not.
but infinity isn't a number.
Infinity is like anything. Yeah. Like,
Well, infinity means it goes on forever. It never stops. So you can't actually give it a number. So you would not really be able to multiply it.
but yet you can say.
But it can be,
negative infinity.
infinity can be more infinite, I
I
guess.
guess there'll be 2 infinity.
Let's talk about that later.
I'm very sure she's mean by.
Okay, so for this one, this is when it's odd and it's negative. So it's going downhill from left to right going down because it's negative. So we would start with the left side, and this says that the y values, the f of x, approaches positive infinity because it's going up, as the x's approach negative infinity, which means left. It always starts with left, so the x's will always be the same every single time, like every time you write these. And then the next one, it says f of x approaches, is going down, so negative infinity, as x approaches positive infinity. Okay, all of these are written here. These are the left ones. These are the right ones. I'm not going to rewrite all of them. These are the left. These are the right. Right. So let's actually look at an example right here. So f of x equals, and we've got negative 0.5 x to the fourth plus 2.5 x squared plus x minus 1. Is this in standard form? Okay, if it's in standard form, we can go on to figure this out. I don't know, it's so funny. Okay, so we need to look at the, if it's odd or even, and then we need to look at positive versus negative. Those are the two things we have to look at. So we always look at the first term to determine this. So this has a degree of what? Okay, that is not the degree, that is the leading coefficient. So the degree is 4, which means it is even, right? What is the leading coefficient? Negative 0.5, which means it is negative. So what does even and negative look like just at the ends? I don't know what goes on in between. I just know that the ends are both going to go down. Okay? Just like if it's not a parabola, but if it was, the ends would go down if it was negative. We figured that out later, not today. We're just going to talk about the end behavior for now. So you just have to now write f of x approaches. So we're looking at the left side first. Down. So that's negative infinity as x approaches on the left side. Where's x going? To the on the left side, x is going to the on the left side.
Positive evidence mean positive infinity.
No, negative infinity, because that's where x is left.
What?
Yeah, I just flipped my page in front of you.
Hold on. What doesn't make sense? The 4 is even, so it's either up or down. But because it's a negative leading coefficient, it has to be down. So the graph might look something like this. I don't know what it looks. Actually, I know it doesn't look like that, but you know, the graph would look something. But it doesn't matter what's in the middle. It just matters the ends. I will hopefully come up with even better notes in my other class, but I will post what I have today. This is the full answer for this. If you need help, you come see me in XH. I'm going to post assignment on Canvas calendar. And you guys, the assignment will be in the book, so you'll do it on paper. Assignment, it won't be very long, it'll be pretty short, on the Canvas calendar.
And your dog. Because he's in puppy.